Okay, to continue the sequence, 5, 11, 31, 71, 137, the rest of these numbers in purple are continuations. We find the differences. Okay, differences are 6, 20, 40, 66. You can verify that. 5 and 6 is 11. 11 and 20 is 31. 31 and 40 is 71, etc. And then we take the differences of this sequence because we don't see any particular pattern to it, to these numbers. But when we take the differences, we get 14, 20, 26, and so forth. Now these numbers are small enough that we can clearly see that these are going up each by 6, so we could continue on adding 6 to get 32, adding 6 to get 38. If we happen not to see this pattern, as might be the case if you have bigger gaps between the numbers, and you can't do the arithmetic as easily, then we could take another set of differences. Now we only get 2 6s here. That doesn't firmly establish a pattern. If we had a couple more, that would be great, but we don't have any more numbers in the original sequence, so we can't get any more than that. So we simply conjecture that if this is a polynomial sequence, and of course you don't have to understand what that means, but if this is the kind of sequence that it might well be, that we expect this pattern maybe to continue so that we have 6s. And then, of course, we can continue the 6s. So this 6 indicates that the next number will be 26 plus 6, or 32, to which we add 6 to get 38, and we can go on as far as we like. Now, what next? Well, we got the number 66 here. Okay, 66 and 32 gives us 98. Add 38, we get 136, and of course I could continue. So now we have numbers here, so we can add the 98 to the 137 to get 235, which we add to the 136 to get 371. Now, just as a point of interest, you don't have to know this, but I generated this sequence by evaluating this polynomial. When x was 1, that gave me 1 and negative 4 and 7, which gives me 5. When x is 2, it gives me x2 cubed is 8, 2 squared is 4, so 8 and 4 is 12. Minus 4x would be minus 4 times 4, minus 16, so now it's negative 4, and I add 7, now it's, negative 4x would be 8, negative 8. So I'd have 12 minus 8, which is 4, added to 7 gives me 11. Then 3, 27, and 9 minus 12 plus 7 gives me 31, and so forth. Okay, that's one technique for continuing a sequence. There are many others. Okay, now we consider the sum of this sequence, 2, 4, 6, 8, 10, and we've already seen this. We group the 2 and the 10 to get 12. We group the 4 and the 8 to get 12. These numbers all change by the same amount. The difference is always 2. So every time we go to the next number here, it gets bigger by 2. But every time we come back a number here, it gets less by 2. So the sum always has to be the same. So the first sum is 12. Every other sum has to be 12. So every pair of numbers here gives us 12. Now we do have a number left over in the middle, but that number is just half of 12. Because it's the average of these two numbers, it's half of 12. So I can say, okay, that's 2 times 12 plus 6, which is 30. Or 2.5 times 12, which is 30. Remember I said you have two pairs, and then this number left in the middle, if there's a single number left in the middle, is half a pair, because it'll be the average of these two numbers, which you get by adding the two numbers, which gives you this, and dividing by 2. So half of a 12, and 2 12s gives us 30. We apply the same strategy to add the numbers from 2 to 100. Now there are 50 numbers from 2 to 100. We could put these numbers in a one-to-one correspondence with the numbers in the set. I said there are 50 pairs, and I just said that completely wrong. There are 25 pairs. Let's back up a minute, because I was about to explain why there are 50 pairs, and my explanation was all of a sudden full of hot air. Okay? I could put these numbers into one-to-one correspondence with the counting numbers from 1 to 50. Just double each number from 1 to 50, and I get all of these numbers. So there are 50 numbers from 1 to 50. We establish that because that's how we count. 1, 2, 3, 4, so forth, and 49, 48, 49, 50. So another way to see that there are 50 numbers here is from 1 to 100 there are 100 numbers. And actually, I need to write out what I was going to say, so I don't want to say that. We're going from 2 to 100, and actually thinking of this as the doubles of 1 through 50 is the easiest way to see that there are 50 of them. Okay, so we have 102 for the total, and every total has to be 102. There are 50 numbers, so there are half that many, 25 pairs. 102 times 25, if I multiplied correctly, and I think I did, gives me 2,550. I think I multiplied correctly because nobody told me I was wrong, and I've got lots of people in the class to tell me if I screw up. Okay, and I hope people will be alert because sometimes I do screw up. Okay, now we want to look at a little more difficult problem. We have the numbers from 100 to 1100 going by fives. So we're counting by fives from 100 to 1100. Well, clearly every pair is going to be 1200. But how many pairs do we have? It's a little more difficult to figure out how many pairs we have here. Okay, well, what we see is from 100 to 1100, there's a gap of 1,000. Okay, we gotta do 1,000 by fives to get all these numbers. Okay, so we start with a 5, and then 110, 115, 120, and so forth. So starting from here, we make a jump of 5. Then we make a jump of 5, and another jump of 5, and then finally we get up to 1,095, another jump of 5 gets us to 1,100. Okay, so what I'm saying now is there are how many jumps from here to here? Well, from this to this, we got to have a certain number of jumps that total up to 1,000, because we got to jump 1,000 from here to here. We're jumping by fives, so we have to have 1,000 divided by 5, or 200 jumps or gaps between these numbers. So here's a gap, and then there'd be a gap, and here's the last gap. So you can think of 200 gaps, or you could think of fence sections. Think of these as being fence poles. How many fence sections are there? Well, there's a fence section between here and here, here and the next, and so forth. There are going to be 200 sections because we have to span 1,000 feet with, say, 5-foot sections of fence. There are many ways you can think about this. That doesn't answer the question of how many numbers there are. Okay? First of all, we have 100. That's our first number. And then we have our first jump from 100 to 105. Okay? And we then have a total of 200 jumps. So we have our first number plus 200 jumps. You can think of our first post and then 200 fence sections. We're going to need 201 posts. We're going to have 201 numbers. So our result is there are 201 numbers between here and here. We can pair them up in pairs that add up to 1,200, and there are 100.5 or 100.5 pairs. Because of course 201 divided by 2 is 100.5. Now there are other strategies for looking at this. We could apply that strategy, though, to these numbers. From 2 to 100, we got to move 98. Okay? Let's say that these numbers represent stepping stones separated by 2 feet. So our first stepping stone is at the 2-foot mark. The last stepping stone is at the 100-foot mark. There are 98 feet to go. And we're going in 2-foot intervals, so there are going to be 49 steps to make if we start on this particular step. So there's 1, 2, and so forth. Okay, and of course we didn't count this because we didn't have to take a step to get to this one. So that's going to be 49 steps, but 49 numbers from 4 up to 100, I'm sorry. But there's also the first step, which gives us 50 numbers. So we're going to have 50 numbers, 25 pairs, and so forth. Many ways to reason these, and we'll look at another way, a little more formal here, in the next video.